Oh, awesome. Thanks. Great. Thank you, Sean. All right. Welcome, everyone, to the OpenWallet Foundation Wallet Interoperability Special Interest Group call for September 22nd, 2025. Let's see. Today on the agenda, we will hear about the trust spanning protocol, what's new, where the project is going, and how to get involved from WenjingC. So thank you so much for joining us. Really looking forward to it. Let's see. We are recording this call. It will be posted on the media page later today. We are, of course, following the Linux Foundation antitrust policy and the OpenWallet Foundation Code of Conduct. Let's see. In terms of announcements, I know we've got IAW coming up, as well as the agentic workshop the day after, as well as the, I believe, the OWF Developer Summit. Sean, are there other announcements that you wanted to add in particular, or anybody else?
The architecture SIG happens exactly an hour from now. And the developer summit, I should have the date finalized by tomorrow, get an agenda out to everybody, and start recruiting folks to speak and demo. So I'm hoping no later than end of day CET tomorrow we'll get that done.
Awesome. That's great to hear. Let's see. Any other announcements from anybody on the call? All right, let's see. In terms of project updates on ACPI, I know the Canon PR is getting really close, and also had discussions about a new name and logo proposed by Patrick St. Louis. So that's pretty cool. Check that out if you'd like. Let's see, still on release 1.3.2. Stephen, are there other things you wanted to call out related to ACPI?
No, not really. As you say, things keep moving along. We're getting close. A couple of the PRs that Maritz has been working on with DidX are completed and completing. So those are moving forward. So again, but Canon is the big one we're waiting on to finish off.
Awesome. Cool. And anybody have anything to share related to any of the other projects in the space?
Likewise, Credo has continuing to have lots of activity on it. One of the more interesting ones was an interesting memory leak that was discovered and fixed, and so that'll be an improvement in performance, especially for high volume deployments. So that's a good thing. So looking forward to, and then, as I say, all sorts of functionality is going into Credo from different parties, focused on different requirements. So it's nicely being organized and managed by the team, by the maintainers.
Awesome.
All these diverse inputs.
Awesome. And just as a note there, we will have a Credo maintainer come to the call in several weeks to give another update. So looking forward to that. Ramik, did you have your hand up?
Yes, just briefly, there's the issue of Axios last week. So anyone using Axios needs to look at do a Google search for it. You'll find there's an issue which affects all old versions of Axios, which affects everything in using JavaScript.
Interesting.
Looking that up.
You'll find anything before 1.12 of Axios is affected.
Okay.
The issues this week have not affected us. I'm checking currently off the dependency checks on how it affects our JavaScript projects, because NPM is getting hammered at the moment via basically people trying to do crypto wallet theft.
Oh, well. Yikes. Thanks for bringing that to our attention. All right. Let's see. In terms of upcoming Wallet Interop SIG meetings, next week we'll hear about the UNICC ID Solutions journey and vision. We will also hear about the digital credentials API and the work that Google is doing there. We will hear about OAuth and other protocols from Tim, who's on the call today. So really looking forward to that. And then, as I mentioned, we will also hear about Credo after a brief break for IAW. And yeah, so that's just a quick look at the coming weeks. All right, with that, are there any other project updates or announcements that anybody would like to share?
I
Yes,
just
David.
wondered if anybody knew why there was a release on bifold, because I don't think Romic or I could find out anything about that release.
It was an update to Credo, and it was to enable, evidently, there's some sort of change in Android for, it's known to me as the 16K change. And quite frankly, I don't know what it is that Android has changed, but anyway, they've changed something and it's coming in November. So the bifold change was simply to upgrade the version of Credo, which allowed for addressing that issue.
Right. Thank you.
Surprised there was no information about it. That's
And
unfortunate.
there is a bifold community call tomorrow, September 23rd, and I will get the details and put them in chat.
Thank you.
Great. Let's see. Any other announcements or project updates? All right. With that, I will go ahead and pass the screen share over to you, Wenjing. Thanks again so much for joining us.
Oh, thank you for having me. Let me see. Share, and does that show up okay?
Yes.
All right, so let me put into a slideshow. All right, I think most people know me, but this might be my first time actually presenting trust spending protocol in detail for OpenWallet community. So we're glad to be here. I prepared maybe over too much material, but I'm going to try. And this slide is also available online too. Let me push out and copy the link. So you want to follow on okay, I have to go back here to the chat. You can go to the link, and that way I will open up all the links there as well. So that's good. So I'm trying to cover a few things, the sort of a high-level roles of trust spanning protocol, its design principles, motivations, etc. And then the two parts, I think, that constitute most of the talk can be major functions of TSP, what it actually does. And then we go into, I've listed 5 examples of how applications, which we call them trust tasks, can potentially run over TSP. So that's like how you may want to use TSP for. And then a little quick show, reasons why you may be able to apply TSP to your work. And if I could get there in time, then do some Q&A. But otherwise, I'm free for the rest of the morning. I can stay longer too. All right, so I'm going to feel a little bit of rush, but shall let me know if there are questions or people's hands raised. I'd be happy to stop. I think the discussion may be more interesting. So I'm going to make a lot of assumptions that people already know to save some time. But the basic idea when we started design TSP, I would say roughly 3 years ago, it's to think about a trust framework in more fundamental way. So I would call it that as a layered approach. Borrowing some of the approaches that I think the original internet was designed. And then we think of, hey, how can we solve this problem? Maybe not in completely new way, but in a more disciplined approach, right? And One of the, I think, first assumption is a long-term verifiable identifier. And Steven just talked about that last week. I think I'm going to have more to that point later, that can support reputation. Essentially, your time horizon is longer than a typical token, for example, or that we typically associate with a session, for instance, right? We want to guarantee uncompromised authenticity and non-repudiation. So a simple way I summarize that is who said what to whom. You want to know those three W's. The last thing I want to mention is a much stronger privacy protection, especially in terms of metadata privacy. Those are optional features, but we thought it would be quite important in this day of age that metadata privacy needs some protection. Otherwise, too much can be found, regardless of what your content itself is private or not. Again, if you flip this side and talk about motivations, the baseline function is like the web stack, what we typically know today, or I would call, typically when people say best practices, we think they are not good enough. And then AI agents are definitely breaking even more of these assumptions that we made, when we were designing those for web. And there's also a difference, I think, between trust and security. So we're trying to build trust or build tools that people can use to, to actually create or maintain some kind of a trust relationship rather than simply security. And then like I mentioned earlier, we want to design the protocol sort of following the internet spread and trying to strive for minimalism, efficiency, flexibility. There's a lot of other nice features we want to have if we want to see this protocol used widely and in practical settings. Here are two links that point to the specification of the protocol. And then, of course, we are covering the code project in OpenWallet. Currently, it's a lab project or TSP. Informally, we are also calling it Teaspoon. So if you see that name, it means the same thing. And that's the link. All right, so let me jump into major functions. So the first one is really the, a lot of the terminology I assume most of us already know. I'm not going to spend time here, so I'm going to jump into the first point of major functions. So the first one really is sort of the most simplest and base case of TSP functioning is to send messages or have I think more appropriate, a directional trust relationship between endpoints using verifiable identifiers. So we can do, pack all those terms. The verifiable identifiers should be able to, that can be resolved, verified, and maintained in long term. And the easiest way would be going to an example that's dig2web VH. So very lucky for me that Steven just gave a wonderful, really great talk a week ago. And I watched that whole thing and I learned it, and I think I want to borrow a few of the things what he said there. Other examples would be like there's group people work on data skid. You may heard about the carry AID, and there are examples that's not necessary in the DID format, nor necessarily centralized. So it can be centralized, decentralized. It can be centralized, federated, and many of the existing systems we believe can be modified in at least some setting to work with TSP. So the starting point of this trust relationship is one of the endpoint learns about identify of the other. And you can have several ways to learn it. And I mentioned one way is that you might have already, endpoint A, for example, might have already another TSP relationship with another party, and that party can what we call refer or introduce you to another. So that's a very common way, or maybe the most common way eventually for learning a new identifier. And of course, if you don't have those yet, this is like, starting testing. You would do we'll call auto band introduction or discovery, and that can be numerous other ways. Potentially reuse some of the existing infrastructure to do that. Once you have that, we keep talking about endpoint, and we really associate with some kind of like abstract term of locus of control. A more practical term would be a wallet. So, you have a secure storage, some way of sort of exercising control over your own data, right? So hopefully that's not too abstract. And with that, you could then adopt one of the what we call verifiable identifiers. And so I'm going to be using DIT-WebVH throughout. And so here's one example of DIT-WebVH. I have a more detailed one here that goes into the three part, the preamble, the skit, and then the red portion is the location of where it is. And we are using a test bed that has a dit.teaspoon.world that would contain the information for resolution and also for verification. So this is the JSON-L file would have all the history for verification. So again, I'm going to refer you to Stephen's talk on how that resolution and verification are done. All right. So now I want to probably go further. Then we have an identifier, we have an endpoint with a wallet, etc. Right? And now we can send messages, and the messages are always over some kind of transport, and we're going to get into some example of those transports later. But it's really have very little requirement on that transport. We will see different types later. And we want to ensure three things that we're trying to summarize into small numbers: authenticity, confidentiality, and metadata privacy. So some people may refer the term privacy more broadly. That includes confidentiality as well. I'm just trying to separate them in some way. So those are the three things. And the message itself contain envelope, payload, and signature. And we're going to get into the details on this slide about how that message is constructed. So if you can start with on the top, the envelope is really just the TSP protocols versioning or header, and a sender and receiver. Both are a verifiable identifier. So think of that as DIT-WebVH addresses. The payloads section is essentially, so I'm showing here the most common or one example of the payload type. There are several of them, but this is the more general example. So you would have some kind of a tag to identify it. This is a TSP payload, and then the type define what kind of type of the payload is only a few small numbers, and then we always include a sender address again, and this I will explain shortly later. And then your payload or your user data, right, or go higher layer data. And that whole thing is then encrypted by HPKE, and I will explain that as well, which produces a ciphertext payload goes into the payload type of the message. And then both the envelope and the payload ciphertext then can be signed into signature. So the three portions of the message. I'm showing here, they are all contiguous, like a typical real message, but they don't have to be, as long as you can put them back and do verification. You are free to decide how to carry them over to another endpoint. Just a quick note here is this is one example of it. They all follow the same structure, but that type will change. And also that we are going over a revision, Rev 2. It's almost done. So some of the examples that you see, the printout of binary or actual encoding, those details may change during revision 2. Okay, so I want to, let me see, so explain the three terms that I didn't explain earlier. So ESSI is basically encrypt, sender, sign, receiver. And the explanation goes into, let me see. So it encrypts the sender means that the sender information, the VID sender information, if you look at the up right, is included in the payload or in the sort of a beginning or the header portion of the payload, and that is encrypted. The sign receiver says the receiver portion, which is only in the envelope, is part of signed. The reason we do this is there's a specific paper around this explaining why, but this would definitely solve some of the large problems. One of them is like a post-compromise recovery of the security system. And this is relatively simple. We do pay a little bit of overhead, but it's a simple, more, I think, provable method of solving some of the really challenging problems without having to resort to sort of a new cryptography or more messier solutions. In both cases, the key for the sender and receiver are derived from the VID, right? The data web VH. So the way you resolve that is you resolve the data web VH address, and you get the document, and that's where those keys are. The HPKE portion is a hybrid public key encryption. So this is different from typical encryption, which use a public key for key negotiation and then immediately use the negotiated symmetric key for the rest of the encryption. In this case, you can think of it as every single message has its key renegotiated, or in a way, it's a single key for every message. So the message is essentially encrypted by the sender for the benefit or for the receiver. Okay, so only the sender could be the provable sender, and only this receiver can open it. All right. So that's the confidentiality, and authenticity really comes down to prove, you do the VID sender and receiver verification or resolution on the envelope, and then you verify the signature. So those it ensures that both the content is authentic, that it has integrity, but also who is the sender and it's to whom it's sent to. So again, we summarize that as who said what to whom. That's a simple phrase to remember. And currently, we provide two type of algorithms. One is it's a ongoing, I think, IETF standard called HPKE, and the other one is a well-known or widely used software, open source software package called Sealbox. The post-quantum support is natively added in TSP. Currently, that's experimental because the algorithms are very new, and we are experimenting with whatever software we have available to us. But the specification have a clear support for them, and we're waiting for this implementation become more mature before we say that it's fully supported. So that's you're welcome to test them. A very interesting way of seeing how that works. All right, I need to jump to the next message. It's on bidirectional. So currently, if you look at this, I use a one directional arrow, and all the TSP messages or relationships are they are directional. So you will say A, towards B, or A to B. Okay, say A is the sender, B is the receiver, right? We think trust relationship are not necessarily always bidirectional. A trusts B it's not means B will always trust A. So that directionality in a lot of applications may be very important. But you could, of course, set up two in a pair and treat them as a bidirectional, and that's also a common way when people like that flexibility. It is very closer to what we are familiar with in the past. The second thing I want to mention is nested messages, and this is essentially just sending a TSP message over another TSP message. So you're embedding a message over a message, and that embedding can be done in a standardized way. And the reason you might want to do that is it will hide the inner message in a outer message, right? And so this help to hide the header envelope information, because that portion is not encrypted. And so that portion of information can be used for snooping and correlation attacks in the same way as your TCP/IP addresses and other information in HTTP header, for example. So one way to sort of give yourselves additional protection is by hiding it within another message, which will be then encrypted. And then the main information I think the correlation would need to use is the pair of the verifiable identifiers, right? And so in this example, I'm showing the two relationships on both sides between A and B, and then A1, B1 will be the one that's hidden. And so your patterns, communication patterns, etc., over A1, B1 will be less likely to be correlatable. Okay, so the TSP protocol gives you a standardized way of establishing these nested relationships, and the nesting itself can be repeated as well. The next one is about routed messages. So we need practical solutions for a lot of things. I'm not emphasizing right here because we are in more of in talking about how do we build trust. But these are very critical for any practical solution, right? So I list a few here: resiliency, availability, scaling, reliability, and the list can be much longer. One of the common example people give is if the two endpoints are mobile phones, they may not all be online all the time. And when they are not online, the message need to be buffered somewhere. So this is a very common way how we do cell phone-based messaging app. And so for that purposes, you need the intermediary anyway. And so, but I'm going to explaining why then we can use this intermediary for trust purposes as well, specifically on hiding the path and give some metadata privacy protection. So I'm not going to go too much into the sort of a routing scheme, etc. But you can think of from A to B, all the links are again directional. And of course, you can have the other side as well. But the two sides don't necessarily need to be completely symmetric. They don't necessarily look the same on the other side, right? So your return path and forward path in a way from A to B and B to A may not look alike. And intermediaries are not quote unquote trusted. So they are there to help you do a job. If they don't do the job well, you would suffer in terms of performance and how you experience it, etc., availability, all those things. But it should not compromise your security or what is being trusted. So they are not part of the root of trust. And you could, so TSP provide a message type that includes a path or a way to specify some part of the path so that from A to B, you can route through some kind of path. And that's why, earlier I was showing the TSP message format. I'm not showing this routed method, but you could do that in very similar way and by extending the type information. And then the relationship, if you look at it in endpoint A on the left side, you would have what we call direct relationship A to P, that's to the intermediary P, but also a indirect routed relationship that's from A to B. So A to B are directly between the two endpoints, and you go through, in this case, 1, 2, 3 hops to get there, right? Each one of them is a direct, or could be a direct TSP relationship there. And then you can combine that with nesting with yet another thing hiding in the middle. Again, I won't run too much through it, but this might be costly, but this would be very well hidden in some way. These hiding are, I have to say, they are statistical, so they are like hiding in the cloud rather than in abstract sense. But if the intermediary P and the Q are doing their job and they are, generally not malicious of any kind, this would be reasonably private for a lot of purposes. Okay. Finally, I want to mention the another very important aspect of TSP. We use a encoding scheme called composable event streaming representation. There is a completely separate spec for this itself, but I just want to mention a few things that's very related to why TSP use it. The Caesar encoding has both binary and text mode, and the two are always aligned. So you can easily, converting from one to the other straightforward. They're aligned. The simple way to explain it that the alignment is achieved by if you recall the like a base 64. The 6-bit and 8-bit, if you think of them, a common term that be divisible by both would be 24. So that is a 3-byte. If you somehow arrange all the coding in those 3-byte boundary as a unit, then you have a good alignment always. And this allows, I think, the translation be deterministic. So it's much more readable for debugging purposes. It's also self-describing in the sense that there's always a type for every object component. so this no type is implied. You will always be able to, the parser will always be able to read the type and know what's following. This also very efficient for a lot of like signatures, encryption, ciphertext, stuff like that. That is can be very long and lengthy, and so efficiency is important for adopting strong cryptographic methods widely. You will see them used over and over, and if this inefficiency will build and over time if we don't do it carefully. So this is quite important. I want to emphasize that. And finally, I think another critical feature of CISA encoding is it can support mixed encoding scheme in the application payload. So the payload itself does not have to use this new encoding. You can stay on JSON, CBOR, or message back. Those are the three ones that support it. And that's very critical, and we will definitely use that in a lot, or if not most, of the applications. All right, so quickly, sort of a recap. So this is the picture I use for reference. You will see the endpoint A and B, and intermediaries P and Q, and this number, the links are basically the important, the protocol interactions, right? On the lower half, I have support systems. These are basically like who are actually providing DIDs, or if you use a centralized, more traditional federal system, for example, that would be the identity or providers, and anything that is not inherently within the TSP definition of those components. So those are frequently needed in order to provide the entire solution. And those are simply the number of the links, again, are what the specification talks about and define how those interactions happen. And we, for testing purposes, it's difficult for one developer to have to build all of these in some way. So we provided in the blue a test bed. Like I did teaspoon.world is one of the support system that provides, or when you create a DID, this is where the resolution would go, and P and Q teaspoon.world is to simulate intermediary. So the developer will only need to be writing code for endpoint A and B and do testing that way. So this is a relatively simple test bed. The other thing I think is important, again, to summarize, is that real applications run in higher layer. TSP is designed as a spanning layer or a interoperability layer, right? It unifies a lot of things, makes trust assurances standardized. It help you do trust relationship management, and hopefully help you do interoperability, portability, a lot of other things. So, but most of the application developers, or we formally call them trust tasks, running on top of it. And so that's what I mentioned earlier as the layered approach. And I think I'm going to then turn into sort of give some examples of what the higher layer application may look like and how people are using TSP to do their job. All right. The first group of examples I'm going to go over are about communication among unique persons. I think this is what OpenWallet mostly talks about. We want to help identify unique persons, ensure strong authenticity, non-repudiation, privacy, and all this stuff. I'm repeating myself now, but here is the first example. This is it started in about a year and a half, or a year ago at least, that Jim Zimmerman presented a case of an attack against, I think, a Linux open source software. And it's an identity-based attack, and this is very difficult. And he did some analysis of what's new about this kind of attack and identify, I think, correctly that it's a confusion between security and trust. Again, informally, a lot of people and myself as well use security to mean a lot of things, or maybe all of the above. But I think it's good to use the term more strictly and separate the two a little bit. So, he also mentioned this is really not about a name, but about a reputation, or how we think about what is identity anyway, right? And this, I thought this is a very good example. And the Linux foundations had several discussions more in depth, and they've introduced us to the kernel group. The kernel group told us how they do verification of kernel developers, which is probably the most sensitive project within Linux Foundation, and they really like the proposal or the scheme that we presented. They want to work with us to find a solution. And so this is one of the slides I presented as a sort of a more conceptual way of thinking about how you could build a solution based on the trust spanning protocol. So in this case, the two big blue blocks are endpoints, or you can think of wallets, and we will have identifiers and then credentials, right? Not too strange to us. And then I've listed a bunch of identifiers there. I want to put the PIT over there as well, so you could use that as your anchor identifier. And then all different kinds of credentials. And so I've listed all the well-known names there. But there are also other credentials I'm going to talk to about. The VRC are verifiable relationship credentials between persons. But essentially, you can think of all the trust tasks as ways of what do you do in the higher layer. And one of the, of course, example is credential exchange. Well, those are higher layer protocols. And you may be able to run that instead of running over existing schemes such as OIDC or OAuth, etc. You could run over a new scheme like a TSP. So that's one way to think about this. And here is how then such a solution can be embedded into an open source workflow, for example, Git, and then really solve these identity problem for open source and Git-based systems. The second example I want to go into is a personhood credential, and you might have also heard about the first person project. And this is one paper that talks about this in quite in depth. I highly recommend it, but I'm going to skip to jump into how they may be using TSP instead. Okay, so here is a diagram. I think in the white paper, I provide a link there. That's very recently published, which is very detailed and go into a lot of areas. But this is the one slide easily talks about the role of TSP. So you have endpoint A and B again, and party A and B, which can use higher level protocols to establish personal relationships, but that is anchored or based on the trust relationship that TSP provides. Here's a more of a step example of the two of the wallets and how they go back and forth establishing those verifiable relationship credentials. This is person-to-person relationship without third parties involved. And you can imagine that all the links in between the two parties are based on a TSP message. So that's a good way of thinking about these problems. And it allows, I think, these protocols essentially, if you think about the credential exchange protocols as in two layers, one in the lower layer, one in the higher layer, and with TSP, the higher layer will be a lot easier to implement or to implement correctly. The second example, third now, sorry, is Matrix, and it's an open source based social media protocol. It's reasonably used, I think, a lot in Europe. In some of the international organizations use them, universities, etc. So Matrix has a so-called federated model. So in this case, the blue round spheres, there are servers, they call servers. And then the orange ones are called clients. Okay, so you have a federation, and the clients can be think of like your person. You have a app, a Matrix client app in your mobile phone. You will be selecting a server to connect to, and the Matrix protocol help the whole federation to work. So you can not only talk to other clients on the same server, but also all the other federated servers and the clients of those federated servers. There is still a problem of portability, because it's not easy to actually take your personal information and relationships from one server and move to another. Each of the server provides its own user identity scheme, its own login, authentication, etc. And so it's not entirely portable, right? In theory, you should be able to, but those things tie you down. And so by using TSP, in some way, you free yourself, I think, to create truly a installation that your identity and relationship are portable. The second thing it can easily provide for Matrix users is content and sender authenticity. We've talked about that already, and shouldn't be too hard to imagine how that's done. And so in this case, they've taken a TSP over Matrix scheme rather than the other way around, and this allows easier to implement. So Matrix in this case become the transport for TSP, and interestingly, it worked very well. And on the left side, I have included a Matrix message, and you will see that the TSP signature is included in there as part of the message. So the receiver can have a stronger identity to verify, and also you could easily port, because you are having your trust relationship and identity in your own wallet, right? The wallet is not part of a Matrix. And you can take that with you anytime you want. All right, so that's all of the ones I've discussed are open source projects. You should be able to actually find more information about these initiatives. The fourth one is about content authenticity online. And this is a piece of work we've recently published in the form of a white paper and then a blog post. I provide those two links. And the white paper talks about TSP as a way of strengthening trust in human and AI interactions. And so this particular diagram is showing how you may combine TSP and content authenticity specification called C2PA. And another third complementary is called creator assertion. So this is adding creator's own identity as an assertion into a C2PA manifest, which then is carried as content or as payload in TSP. And these identifiers will then link together to draw essentially this picture. So if you are a third party or a, let's say, a social media provider, for example, you will be able to use the information to provably reconstruct this picture, and therefore give a full picture of who and is working with whom and to produce what, right? And hopefully this is not too hard to see the picture, but I won't have time to go into the detail following the link. But I recommend, of course, the white paper and the blog post on how we may use these three pieces of a specification together to provide a solution on highly trustworthy, I think, social media. The final example is running AI agent protocols over TSP. So we provide a new trust framework again and two AI agent protocols. So the examples I'm going to use are MCP and A2A, as especially MCP. So we label such layering and just to be to make it distinct as with a letter T. So for MCP running over TSP instead of HTTP, right? We'll call that TMCP. And so this is just for easy clarification. I won't go too much into MCP or A2A in any detail, but this is the one slide basically showing, these protocols are now playing a very important role of, of how people are constructing AI agents. And it really becomes a very important part of its architecture for AI agents. And there are many protocols being proposed, and MCP and A2A, AMP, and the list is quite long. I've included a survey paper if you're interested to find out more of it. I've given an earlier talk about what is missing and why we're working on this. And again, I will point you to a YouTube video recorded for one of my presentation back in May of this year. We think the current, again, web stack not very secure and definitely have no good basis for trust. And so those are the S and T that I want to talk about in the video. Again, I'm repeating a little bit on what the best practices are not sufficient. And again, some of the links are included here that goes much deeper talking about what is missing. All right, so very quickly, this running MCP over TSP it's relatively simple, straightforward in very high level. So the left side is the old stack, and the transport is also can be replaced, but in other way, because TSP doesn't really care too much about the transport, which one you may be using. We can run TSP on top of it, and that provide a message-based interface. So JSON RPC can run over that, and which essentially MCP can run over this new transport, and it's a fully standard and supported. And then we're going to talk about once you do that, what kind of things you can do. This slide shows how you could make this whole thing very easy and convenient for developers. So in this example, we are replacing an old API or library SDK called FastMCP into a new version, TMCP. They are essentially identical in how you use it. But instead of this double quoted my app as simply a casual string, now you can have a name, and this name would be actually linked or bound to your DIT-WebVH or any kind of verifiable identifier, and be very strongly identified as your true identity. It's a very important step. In addition, that it gives you all the other features we talk about, the authenticity, confidentiality, and potentially privacy. Similarly, for A2A, This is the a common scheme of how one might use A2A. This is in their example, and we essentially propose to put some of those API keys and agent card, which is essentially a document talking about describing the agent, what can do, what that sort of thing. In a way, very similar to like a did document in a way. And so we thought those would be, part of information should be kept in the wallet, and the agent card could be a type of credential, and then your A2A server SDK would become a TA2A server SDK, and so very similar methods. This will be my last one. Talk about how you may apply this to your trust tasks. So the trust tasks are basically any application or system one may be working on that have a trust or security related challenges, and this is so by using TSP, I think we help you to get a much stronger modern trust framework. TSP has a basic model. It's really simple. It's just asynchronous messaging. So it's very easy to adopt and compatible with many applications. In OpenWallet, there are many projects produce a very good wallet implementation. The so-called controllers, which will have a lot of features that you already implemented. The transport mechanisms are very flexible. You could use common internet or web, but also Bluetooth, embedded environments, emails, messaging. We just look at the matrix, for example. So you can go very low layer or in much higher layer as well. It's easy to adopt. They are based on asynchronous messages, and you can be either text-based or binary. And we believe that we integrate a very strong cryptography. We think that's no longer a bottleneck for most of the modern environments. And so hopefully this will be making your application a lot easier to implement, to make a correct in terms of the security and trust model, and be interoperable as well. All right, my time is running out, but I'm supposed to show you a TMCP AI agent example, and this is the components that they would put them together. So a MCP example goes into the client will talk to an AI model, and you will have a link to integrate a tool. In this case, it's an MCP server. And in my demo, the tool will be a DuckDuckGo search engine. So you would do as a question, the client will talk to the LLM model. LLM will say, hey, let's do a web search. And the web search will go over this MCP over TSP link to a remote search engine, found the answers back or data back, and to the LLM. LLM then will summarize it, do some analysis, and give you a reply. Okay, that's what the demo goes. Have a link here, but I'm going to jump over now so I can use my last minute to say, any kind of questions. And also I've listed the 3 events that's coming up. IW in October, and right after that there's an agent protocol workshop as well. And then the Trust of IP community is organizing a remote symposium in November, and those are official announcements coming up soon. So maybe let me stop here and use the very last minute for questions.
Awesome. Thank you so much, Wenjing, and great to hear about the upcoming events. I know there was a question from David in the chat about are the intermediaries stateless as well, not trusted? If you want to answer that one quickly, or if others have questions, or just this last
Sure,
bit after
let me
that one.
see. So the intermediaries are not trusted because we don't have any keys or anything that typically we consider as the root of trust to the intermediary. The intermediary, unlike, for example, if I rely on for instance, like a cloud like a Google or Amazon cloud, you would have to trust the cloud and administrators, for example, the operators of the cloud. You commonly, for instance, log in and they know, of course, if they want to. You potentially a lot of times put your keys and things into that system. The intermediary in TSP don't do those jobs, so they are not aware of those. The intermediaries are also don't have a way to decrypt your information. So again, the detail we may need to get down to exactly what they know, but they typically don't know any of those information cannot decrypt unless you send directly to them. And the last thing I want to mention is that the intermediary doesn't know the entire path. Again, if you have only one, it would be easy to know. But in the example I'm showing, you have two, the intermediary will only know one half of it. So potentially you can hide further and further if you get this a little bit longer of a path, so that a third party would be difficult, not impossible, but would be very difficult to find your entire path. Besides, your information or your path is per message. So you could be doing quite a bit of hiding, and it's not a session that lasts long, which you potentially, a third party could eventually find it. But if you do it in the right way, there's a bunch of other tools built into it to help you do it in the right way. So hope that answered the question.
Awesome, and it looks like Jim has his hand up as well. I just need to jump in quickly. I have to hop off for another meeting at the top of the hour, but Wenjin and Stephen, you two are co-hosts if anybody's able to stay around for more questions.
Thank you. Thank you. Yes,
I'll hop off here. Thank you so much, Wenjin, for the presentation, and I hope you all have a great discussion from here. Thank you so much.
Okay.
Bye.
Thank you. Jim?
Hi, thank you for the presentation. I'm sorry I missed the front part of it, but it really looked good in addressing a lot of what I call existing problems with the concepts of how you're implementing trust spanning protocols. Besides all, and you did, I'll call it beautifully, bring up many of the issues that are default trusts that we don't have control over today. That we grant to all of these platform services. And your protocol, in a sense, provides a lot more control over those trusts, which is excellent. The only thing I would throw out there is, as an example, your social media diagram showed a bunch of servers and all that. And the challenge of most of these things, like the matrix network, a lot of them, is we have in the real world, I'll say users, organizations, agents, all of them, teams, whatever, have very sophisticated rules on sharing and confidentiality that generally aren't met well by the existing platforms. So what that means is like in the social media example, if I have, I'll call it Jim's set of resources that are mine, that I own, they may be on different platforms, and I may have different what I call logical views that I want to authorize for those. So as an example, and using this team as an example, I'd say maybe you have a set of resources that you want to make accessible, but it would only be to Bo and Stephen, and not maybe to the rest of us on this call. And so that would be one logical view over your stuff. And so one of the challenges I see in those network models is being able to enforce, I'll call it custom views on confidentiality of resources, if that makes sense. That's all. But thank you very much. I think this is a huge leap forward. I'll say that. So thank you.
Thank you, Jim, for the kind words and also the question. So I think we are thinking in a way of again the layered approach. we thought it would provide a foundational framework that these things could be achieved. It is by itself does not, solve the problems you mentioned entirely, and so we might be moving, for example, some of the solution to where the application developers can then build on top of it and provide those solutions. But at the end of the day, right, those relationships need to be managed in a convenient way. And today that's provided by a combination of the so-called platform, but also usually the same platform give you the application too. And that's where I think these issues are. And now we provide a possible alternative where the applications can build in much more user-facing or user-oriented benefits based on a TSP design. And so we hope that at least provide the possibility to do that. And the matrix example I cited is a early stage sort of a prototype people are working on. Could be, one example of how you may be able to do this and still maintain, like we do think that the platforms need to recover their costs and they need to be, to provide still same way, provide you a lot of services, whether paid or not, right? And that we hope that they would continue, and therefore there will be more healthier collaboration between the two. And in a way, that's, I'm just thinking out loud one potential way this can go. Stephen.
Yeah, just a quick question. One of the things I've always been interested in is how TSP compares with DIDCOM, and I think their goals are the same and it's an implementation, but I'd love to find a resource that sort of compared the two and noted where they differ from concept and where they differ in implementation. Is there such a resource around?
I've done several times, but have not compiled in a systematic way. I'm trying to avoid. I think so. Maybe I've delayed a little too much, but I'm hoping that people get to know, a little bit more, and then we can carefully maybe thought through like where exactly the differences are, and maybe put them together. So I'll be happy to do that if I could, recruit you, for example, so I don't say anything wrong. If you can help me, and I'd be happy to do that. But I can verbally summarize some of the things at least come to my mind will be the top level differences. And the one I think I mentioned in most of my presentations is a methodology. So we're trying to be more thorough and be minimalist. And so that we keep doing only the lower layer things, and we trying to give the higher layer freedom, as much as possible to do what they need. We try to do.
I was thinking just the DIDCOM envelope, because I think that's where the similarities are. The DIDCOM envelope, as opposed to the defined DIDCOM messages, some of which are included in the DIDCOM spec.
Correct. The envelopes,
okay.
and we also use ESSR, for example. That's kind of different. CZ coding is different, and so there's a bunch of things.
Yeah. Again, I think the biggest thing I wondered and would love to know is just where it differs on conceptual versus, I know the details are quite different. But it would also be good to have just here's the conceptual differences in them. And that's part of what you just said. So thank you.
Yeah. Some of I think those are the conceptual differences. And the things I mentioned, right? Why they are different is because we start from a different conceptual orientation, at least how we started. And then we end up going down to different routes of how we implement.
Well, thank you so much for this. Much appreciated. Looks like we're set. A few minutes over, but well worth the conversation. That was an excellent presentation. Much appreciated, and we'll get it posted.
Thank you. And again, if you want to see the demo, there's a link there. It's a recording.
Yeah.
Not have time to do it.
I'll try to grab it out of the presentation. You've sent the presentation over, right?
I give you the link. Do you have it's in the chat.
It's in the chat. Okay, I'll grab that. Let
Yeah,
me
I
save the
think the
chat,
link
make
is
sure I've got
open
that.
to anyone.
Good. Excellent.
Perfect.
Thanks all. See
Thank
ya.
you.
Thanks, Wenjing.
Mm.
Wenjing.
Bye-bye.